Technology, right? Who even likes technology? We are doing the reading group today. Hello to YouTube, live over there now too. We don't have anyone currently on the call. It sounds like Fembox plans to be here, but be a little late, which is fine. Regardless, I want to try out this little whiteboard app because it seems really nice. And since for now, at least, I'm the only one here, I'm gonna just choose a problem and go with it. That's the penalty for being late. Which one do I want to choose though? Why did I open that image twice? Ooh, yeah, let's take a look at number 21 from the book. So the nice thing is you can just copy and paste right in there, which is nice. Oh, hey, Fembox. I can't hear you right now if you're talking.
Okay, I'm here now, I think.
Oh, hey, I gotcha. How's it going?
Doing good. I'm getting some feedback. I wonder if that's on my end.
Oh, yeah, to me you sound fine.
Okay, I was hearing it through the stream and the Discord. Okay, I get it.
Oh, okay. That'll do it.
Yep.
So if you just want to, or if you're not interested in being on the whiteboard, it's no worries. But I was interested in trying out this like website for whiteboard instead of the Discord one. And so if you want to find the link, it's kind of in a weird place in Discord, but I can help you find it if you want to find it.
Right click on voice chat and go to open chat. Let me try it.
Okay.
Okay, I'm at something.
For me, it opens up like a panel on the right with the actual chat, and I put the link in there.
Uh-huh. Okay.
Just that way random people can't like hop on the whiteboard and draw something bad.
Okay.
Okay. Actually, are you able to like change your name? I wonder. Actions. Ooh. I saw you pop up. Okay. Cool. It seems to have like similar controls where like you hold right click to pan, you can scroll to zoom in and out. And by default, you're on the select tool, but on the left side, you can like change to the pen and I guess like text and shapes.
Am I the visiting pioneer?
I think so, yeah.
Okay.
I can find a way to like change your name. Maybe you have to make an account to do that, but it seems like we can also just use it without an account. But yeah, so I just kind of went and chose 21 because it seemed interesting, but do you mind this one or do you have a preference?
Looks good. Looks good.
Okay. Position right? Okay. So we have a distribution of charge with cylindrical symmetry. So function of the distance r from the symmetry axis, the electric potential is, and we have this piecewise defined function. So the actual radius of the cylinder is 2 big R, but there's, I guess, 2 different stages of potential. So potential is actually constant for the first like half of the radius between 0 and big R, but it scales with between big R and 2R. Rho now is a quantity with dimensions, volume, charge density. Find and make rough plots of the electric field and charge distribution. Okay, so we need to use our formulas to find rho and E. And we need appendix F to help with that. Oh shoot, which one of these formulas do we want though?
Oh, I got my printout of that cheat sheet right here.
Oh, nice. So I found the derivative operators and I realized I don't even know which ones we need yet. Sniffing tool. Oh, it even has like alignment for images. Ooh, that's nice. Really load this thing up with images and see how many can handle at once, I guess. Okay. Oh, nice. Going on that graph. So we have B, and we want rho, and we want E. So if E is minus del B, then del in cylindrical coordinates I assume I want the third one right here. We have to do it for each of the 3 pieces, though. I guess the first one is constant with respect to small r. So without thinking too hard, we can just say del phi is 0 for small r less than or equal to large r. Oh, and you're finding that phi, it starts out as constant and then it's a downward facing parabola?
Yeah, I'm sort of trying to guesstimate what the graph looks like. I think that might be what it would look like.
Yeah, the vertex of this thing is going to be at rho naught over 4 epsilon naught, or maybe over 8 epsilon naught. Minus b over 2a. Yeah, I guess we should make sure these things actually meet and it's continuous. It should be, right?
I checked that. I think it is, yeah.
Okay. Oh yeah, it definitely is continuous. Okay. So that kind of forces the parabola to look a certain way. And the 0 you're saying is at 2r. if small r equals 0, don't we get rho naught r squared over epsilon naught?
You're saying if small r equals 0?
Yeah, like, right, like that one. Or no, I'm not thinking about the parabola, right? You said this thing equal to 0. Never mind, I'm doing it backwards. You don't plug in 0.
Oh, I see. You're trying to find a vertex. Oh,
Yeah, I
yeah.
was trying to find like the root that you grabbed is 2r. If you do plug in 2r, you do get 0, so I guess that makes it easy. Okay, I agree with your graph then. That makes sense.
Okay.
And I was just trying to work on finding E using this, I guess, the third line in the appendix.
Okay.
But the top row is just a constant, so it's 0. The middle row, I guess our partials are 0 for theta, like df d theta and df dz. Oh, I'm overthinking it. It's still a function of one variable, so
Oh, yeah. So
it's just gonna be the
it's just partial df dr r hat, right?
right. So the sign's gonna flip to be positive 2. Okay, so rho naught small r over 2 epsilon naught. If I can do this mental math right. I think that's okay. And then it'll be 0 again for the third line. Hey Joseph, is that just a blank line? How did you do that?
What? How did I move it?
Oh
There's a
no.
lasso.
So, sorry, Joseph managed to figure out how to put a blank line in chat, at least on my screen.
Oh,
But there's a lasso? Where's
yeah.
that?
I can see it on your screen right now. It's in the pen menu. It's
In the
like the
pen?
fifth one down,
Oh.
just below the black arrow, right? The second choice, click that, and then you see a little lasso.
Ah.
Yeah. You
Okay,
can
I figured out you can
move
draw a
things.
box, but the lasso is even nicer.
Yeah.
Okay. Oh, it is an emote. It just Twitch is being weird and not loading it. Okay, and so I guess what I found for E, which I guess I'll draw to the right of what you did, is just we have 0, a line, and then it goes right back to 0.
Can we move the graph? If we move the graph over, then we can keep the vertical, keep the scale the same, maybe. No, it's going to be good. It's going to be good.
Okay. Yeah, I mean, I think doing about the same scale is a good idea. Um, can I get like, I guess like a thicker, there we go. And then how, when small r is equal to 2r, how high up does this line go? Rho naught big R over epsilon naught.
Yeah.
Okay. Oh wait, that should be a closed dot in the end, or open dot. Not that really matters, but Okay.
Nice, nice.
Then I guess we also need rho for the last part of part A. And we need the Laplacian there. Also, so for this, cylindrical coordinates are going to matter because we get a factor of 1 over r and a factor of r. Minus epsilon naught Laplacian b. Let me just say off the bat that's going to be 0 for the top and bottom like before. This one, I think I am not going to do that mentally. We do r times df dr, which I guess we already got df dr for phi. So we would do 1 over r d dr of r times the thing that I got in the last part.
Okay.
Like
Oh,
that.
so then the R's cancel.
Oh, they will, yeah.
No. Oh, wait, no. Will they?
Because we get 2 rho naught r 2 epsilon naught. So yeah, the r's are going to cancel here. Rho naught over epsilon naught? Oh, I guess that makes sense because the density is just rho naught.
U's cancel, R's cancel.
Oh, there's a negative sign here. But that's
Oh,
good.
is there?
Yeah, because the answer for
That's-
E, you stick a negative sign in front, but that's not there for the formula for rho. See, if you go back and take the derivative of B, there's a minus in front of the small r squared. So that's a good thing, because in the formula for rho is another minus sign, so it's going to still turn positive. Oh, shouldn't we be getting... Oh, wait. I made a bad assumption for the first line. That Laplacian is not going to be 0. Because you multiply it by r. No, maybe it is 0. df dr. No, I guess it is 0. That feels weird, because I thought there was going to be... No, I guess it makes sense. It's like a tube. Probably. So...
All right. So let's plot that one.
Yeah. So we can do a third graph on the right there, yeah.
Yep.
This one will be a much more boring graph, though.
So you got rho naught, constant rho naught from R to 2R. Okay.
I think that makes sense, because it's just the density. Yeah, it does feel a little, like, simple. Let's get a little step function there.
Oh, I got graph envy. Your graphs look better than my graph does. I got to get used to this whiteboard.
It already feels a lot better to me than the Discord one.
Yeah, it seems nice.
Oh, Jets, that 75 streak. Jeez. Nice. Okay, so that's part A done, I think. From your charge distribution, calculate the total charge per unit length along the cylinder.
I think we should, let's look at these graphs for a minute.
Yeah, sure.
Because I think it's worth trying to, at least for me, it's worth looking at these graphs and trying to see how they relate to each other, right? So I can get this, the potential and the field and the charge distribution. I want to get the relationships in my head. And
Yeah,
I think
sure.
they're basically just like derivatives and integrals, aren't they?
Mm-hmm. And so I guess the derivatives, you start with phi and you go to the right each time. It's like parabola to slanted line to flat line.
Yeah. And there's like scaling factors like the epsilon naught and negative signs and stuff, but we just have to make sure we don't lose track of them.
Right. And I think physically what this thing looks like is like a tube with a hollow middle and a solid, like, a charged outside.
Yeah. So like
Somehow there's no field on the outside of this thing, though. I don't quite understand. Because you're only ever doing work once you're actually inside. And then as soon as you've broken through that last like inner barrier, you're not doing any extra work. So there must be something extra here that's canceling, I guess.
so it's sort of like a cylinder, radius 2r, but there's a hole in the middle of it of radius r. Is that what we're thinking? And then it's
Right.
uniform charge distribution. Okay.
Maybe the shape tool will come in handy. Draw it better. Can I set the radius of this? That'd be great. Not that I see.
Pretty nice.
Awesome. But that still doesn't it doesn't account for the field being 0 outside of this, which is really weird. Like I'm wondering if there needs to be some kind of like, well, I guess I wonder if there's like some positive part and some negative part or something, but that doesn't make sense. This feels like the type of thing where when you look at the answer in the back of the book's going to say like there's some like infinite plane off to the side or something.
So how did you find the field? You used the gradient, right?
Right.
The gradient of the potential function in cylindrical coordinates. I mean, the gradient of 0 is 0, right? I mean, it's got to be.
Yeah. Yeah, I guess the density that we found doesn't lie. I feel like it should show up in that function. You're right. If there is something else.
Didn't we do some kind of problem sort of similar to this once before, where we had some kind of a function that had this same kind of jump discontinuity, and then in the book they said, well, that just means there's some accumulation of charge right at the surface or something like that.
Something? Yeah, like it might have been the one right before this one, number 20, That was pretty similar.
Oh, did we do that one?
I think we did. I don't remember though.
Yeah,
But
it's
I
been a
remember what you were
while.
talking about. Yeah. But I don't know. I'm
All
willing
right.
to just go with this, I guess.
Yeah, let's try the second part.
Total charge per unit length along the cylinder. Um, so converting this to a one-dimensional density, I guess. Total charge per unit length along the cylinder.
Oh, so do we just do rho naught times 4/3? No, not 4/3. Rho naught times 2r squared minus r squared or something like that, like the area of the cross section.
Yeah,
Is that
that's
all it
what
is?
it probably is. Like, can we just take like a fixed 1 meter height of this tube?
Yeah, unit length. Yeah. So isn't that just 3r squared rho naught?
3r squared rho. Redo like pi r squared?
Sorry, I forgot the pi, didn't I? 3 pi r squared. Yeah.
Okay. And that'll be from. I feel like we need a. Well, I guess that there's already 2 dimensions there. Pi 2r squared minus r squared. Oh, that should be 4. Oh, I see where you're getting the 3 now from. Okay. So that's the, like, I guess that's like the surface area of the top and bottom. But if we get the volume, that's not good either.
Well, if you multiply that by the 1 meter height, is that okay? That'd be the volume.
Um,
And then multiply by rho naught, we should get the charge.
oh wait, yeah, the volume of the cylinder actually might get my formulas mixed up. Oh, it's pi r squared h. Oh. But yeah, I guess we have this much volume per like 1 meter height. No. But I agree with saying just multiplying the row not in there. So I want to make sure that it seems like check it like dimensionally. I'm trying to make sure it makes like I can explain it a second way too, I guess.
Yeah, rho naught coulombs per cubic meter. And how many cubic meters have we got? Well, we've got 4 pi r squared minus 1 pi r squared times 1, right? I think it's right.
Um. Yeah. It's another one that I'm okay with just like going with it. C per.
Does it make sense?
I guess I'm trying to like maybe like figure it out like if we want charge per length, we have to like that's the same thing as like I'm trying to make this like more complicated, like charge per the thing that we have over the unit length or some kind of like I guess that's not exactly right.
Oh, I see what you're saying.
Something like this to maybe like make me feel better about it, but I don't know how this actually works.
I think you got an R cubed there instead of an R squared.
Oh, I don't know why I made that a cubed. Oops. Hey, Milk.
I'm a little bit concerned because part B seemed too easy. I feel like we might be missing something.
Yeah. It's equal to... That's our theory, Milk, yeah. We were just given this function for phi, and we're told to calculate charge density in the field. And so once we looked at all those, I think you might coaxial cable is probably a good word, but like we're even calling it like a hollow cylinder. And so I think we've done part A properly as far as I can tell. We're working on part B, but we got something that probably makes sense, but I'm having a hard time like justifying it physically.
Oh, did I get booted out of the thing?
Oh, on my screen you're still here. It says you're idle for some reason, but oh yeah, it's on my end. You're here. I'm not sure.
Yeah, okay, I'm still here.
So, yeah, I do feel like there's something more probably that came in with part B, but I can't really figure it out. Like it's one that I'm willing to check the answer on.
I think provided that we have part A right, I think part B seems right because, if rho is constant through the cylinder, then basically they're just asking for, what's a unit length volume of the cylinder, basically.
Yeah. Let's see, it's 21.
Like you said before, it's just that electric field being zero outside, which is kind of weird.
Yeah.
It makes sense it would be zero inside, right? Just by symmetry or whatever.
Yeah, you make like a Gauss's law solid on the inside.
Right.
I still don't, I was doing that last night. I still don't get physically why that works. I understand like the Gauss's law application, but like I feel like it should be just pointing into the middle intuitively.
It's always felt to me like if you're right at the middle, then by symmetry it would be zero. But it feels like
Right.
if you're kind of inside the cylinder but close to the inner surface, that when you're close to the surface, that you'd kind of feel a field because you're closer to one side than the other, But I guess I think I've seen it prove that that's not the case. And I know
Yeah.
by Gauss's law that's not the case. So
Right. Maybe like the Coulomb's law kind of like vector justification to that. If you're closer to one side of the shell, like if you have a charge right there, then there's a bigger fraction of the circle. Like even though
yeah,
you are closer to one end, a bigger fraction of the circle is pushing away too, which is where you get that cancellation.
yeah.
Inverse square law. Oh, it has something to do with the inverse square milk. Oops, wrong tab. That's something maybe to review the chapter 1 on again. Um. Oh, I think I'd get a point marked off for forgetting the R hat for E. Is everything else right though? Rho R
Looks like,
2 epsilon. Oh,
oh,
what's up?
so did we get the vertex wrong? I had thought the vertex was where the potential graph, right? I tried to graph it like the parabola was coming in tangent to the horizontal line there.
3,
But
not.
maybe I should have checked that.
Oh, it's not necessarily the vert. I see what you're saying. Yeah, that doesn't look like the vertex.
Yeah, because the field has a jump there at R, which
Yeah. So I messed that
why
part
is
up
that?
too.
I thought when we did the equations, we didn't get a jump.
If you. Oh, yeah, according to what I did. Huh. How do
Oh,
they
there
get a
is a jump.
constant?
Good heavens. Yeah, no, I get it. Because
Oh, you plug
I
in
get it.
R, that's
Because
0.
yeah. Yep.
Dang it. Ugh. Okay, I want to fix this graph.
Okay.
Okay, I guess I'm getting a bunch of points marked off today then.
That's fine. Just imagine all the people who aren't even studying electricity and magnetism right now. They're all getting 0, and we're at least getting some points.
True. Yeah. 2 epsilon. So I get what also is the vertex of this parabola? Minus b over
Yeah,
2a.
let's check that. That's my bad. I was a little bit quick to graph that.
I mean, I agreed with it.
You're going to agree with me. That's probably your first mistake.
That's a weird 2. And then that's C, this is A. So minus 1, or wait, the vertex is 0, because B is 0. Unless I'm crazy. Me. I'm gonna Google a very, or I'm gonna open up a very basic parabola right now. Okay, yeah, the vertex is at 0. Interesting. Okay. So this parabola, it would be if r equals 0.
So it should have still been coming up, huh? At an angle, I mean, at that point. When little r equals big R, my potential graph should have been coming up at an angle.
Yeah. Okay. Just write a little label there for future reference.
Oh yeah, because 4 capital R squared minus little r squared. Yeah, so it's 2r minus r and 2r plus r. So it's 0 at plus minus 2r. So the vertex is right in the middle, like you said, at 0. Okay. You can trash my graph and make a better one if you want.
Uh, I was thinking about that, but I think I'm too lazy. It's already like nearly there. Just gotta be clear that it's not the vertex there.
How did you get the your nice thicker lines that you have there?
Oh, in the pen tool, if you click like once on the thing you want to, like you have the 3 different pens, and you click on it like twice to edit that pen. So you change the color and the thickness.
Oh,
Like those bottom 3, you can all like edit them.
oh, there's the thickness. I see it. Yeah, thanks.
Actually, I should probably edit these. That's thin. There we go. Okay. Let's. Cells for E. Oh.
So you know what? It comes up to 4 here, 3/4. So 4/4 right there. There we go.
We at least did get row correct, although it seems like there might be some nuance here.
Yeah, they got these arrows pointing, don't they? That's some kind of a point charge, right? It
Uh,
reminds me of the Dirac delta function or something from differential equations. It's like you got a impulse or something, right? Like something's jumping from 0 to infinity and back to 0 right there.
oh, like I think I may learned as like the heaviside function. Is that it?
Uh,
Direct delta might be
the
different.
heaviside function is a step, but the delta function is an impulse, which means it gets
Oh,
unbounded just for a second.
oh yeah, this is different. Okay. The integral of this thing is 1? How does that work?
Yeah. You
Okay.
got me.
Yeah. One of those weird things, I guess. Okay.
You take a limit of like a square pulse, right? Or rectangular pulse, and you let the base, so the area of the rectangle is area 1, and you divide the base by 2 and double the height, and you just take the limit as you continue with that.
Oh, I guess one of those things where like you keep that product finite or something.
Yeah, exactly. You keep the product equal to 1.
Okay.
And I guess they use that function in physics to model um, impulses, right? Which is a force that's applied over a very, very small period of time, like
Oh, right.
hitting a nail with a hammer or something, right? That's what the graph of the force would look like on the nail.
Interesting. Okay. I learned a tiny bit about impulse, but I remember that was one of the things like I understood the least in mechanics. I don't think we ever went as far as direct delta though.
I think I learned about that in differential equations because it came up in Laplace transforms. I remember.
Oh, yeah. We only barely touched on Laplace transforms. I think that's why I learned about heaviside though.
Yeah. So look what they say. We're not done. The discontinuities in ER at R equals R and R equals 2R imply that there are surface charge densities there. So it's the jump in the field, right? The fact that the electric field jumps is telling us that we have like right there we have a charge density at the surface.
So we have two extra like sheets on the inside and outside. Is that what?
Yeah, I think that's what that is.
That would make
Like
sense
we
for how
have
something
a
could not show up in the row function, I guess. Well, these are terrible circles, but huh.
Yeah, so like a uniform volume charge density inside the cylinder, but then surface densities on the two surfaces that are different.
At R equals R, the field jumps up by rho naught R over 2 epsilon naught, so the surface charge density must be sigma sub R equals rho naught R over 2?
Oh,
What?
sigma over epsilon naught. Yeah,
Oh,
they've been talking about that, right? As you go through a surface from like one side to the other, they say the field jumps by sigma over epsilon naught.
yeah, I
Or the
thought they're going to take the average on either side. This is something else.
That's really cool. So they could find the surface charge densities on the inside of the cylinder and the outside.
Yeah.
So do we have to factor that into part B?
Oh, that might be it. I still don't quite get how they got these numbers for, or like the expressions for sigma. We can take a look at part B.
They're saying from Gauss's law, the change in the field across the surface is sigma over epsilon naught.
Surface equals. Variables are surface density must be. So are they doing like oops.
Yeah, they're doing the
Sigma
cross-sectional
over
area,
equals.
the cross-sectional area to with the volume charge density, right? And then they're doing the circumferences with the surface densities. Very tricky.
Wait. I don't think this makes sense. Oh wait. Oh, okay. Let me. So I thought what they were doing going to apply that like average thing they talked about in one of these chapters, and I just want to see if this formula does get what they said. Like you take the average of, I think it's supposed to be the field on the inside and the field on the outside. What is that? Rho naught r over 4. Is that what they got? No, over 2.
I think I remember what you're talking about. That was the end of chapter 1, right?
Yeah.
Those last couple sections in chapter 1 where he really turned up the heat.
Yeah. Well, thank you for the 1 bit. Oh, it is a corgi, yeah. Oh. Well, I guess I was thinking of force per unit area with that averaging thing. I swear it was something else, though. Huh.
They were talking about that again at the start of chapter 3. I just read the first 5 pages of chapter 3 the other day, and they were talking about this sigma over epsilon naught again.
Oh, they were? I can
Yeah, when
see
they were talking
rho.
about the electric field at the surface of a conductor had to come at right angles to the surface.
Oh,
And
yeah.
they showed some graphs of surface layers and going from one side to the other side and how the field vectors changed on each side. And they had 3 or 4 different pictures. Anyway, that's getting ahead of ourselves. I know we're not into chapter 3 yet.
Yeah, I'm still only like halfway through. It's not easy. Okay, maybe
Oh, you don't,
a what?
I was going to say you don't want those cheap viewers.
No. I only want the expensive ones. All right, let's at least look at part B. Cheap
Yeah.
viewers. Cross-section area of... Okay, we just got to 3 pi r squared.
Yeah, we got the first part right.
They have an L
We just
stuck in front of it, though. Oh,
they're
there's
gonna
the inner
divide
length
by
L.
8.
We took the L to be 1.
Yeah.
Okay.
3 and 1 is 4 minus 4 is 0. I'm just taking those 3 numbers and adding them together, and I'm getting 0. So they're going to say there's 0 charge per unit length.
And by L, we see the total charge per unit length is 0. Otherwise, there would be a non-zero field outside the cylinder.
Oh, well, there you go. That answers our question. Like we were like, well, what happened to the field outside? Well, it's 0 because there's no charge. Wow.
That's absolutely crazy. So if you have 2 cylindrical sheets, that's the same thing as like a filled-in hollow cylinder that goes between those 2 sheets if the density is the same.
I mean,
Like,
is that true in general, or is that just based on the way they set the potential function up in the first place? They might have done something sneaky to make that come
um,
out that way.
well, I think a normal infinite cylinder scales with, oops, I keep on going to the wrong thing, with just R, but maybe the extra coefficients they had mess with it. I definitely remember inside a sphere, the field definitely scales up with, or I guess it decreases with 1 over R. For inside a cylinder, I can't quite remember if it's the exact same, but I know the outside is 1 over R.
Yeah, that sounds right. 1 over R.
Yeah, you're right. This might not be like generalizable, but it's still interesting they set up to get like exact cancellation there, I guess. All right. I guess we can look for a new problem now, unless you have anything else on that one.
Now let's soldier on.
All right. It's a cool problem.
It was cool. I feel like I got to do all these problems again.
Yeah. Same. Hmm. Um, maybe 24? Let me bring it up on the board. I guess let's put all of that in a box, what we just did as well. Okay, so this seems like just a little bit of doing calculations.
Yeah. Cartesian.
Yeah. But I'm not all that comfortable with these operators, so at least for me, I think it'd be helpful to see this one.
Yeah, for sure.
Various derivatives and Cartesian coordinates. Um, And so I wonder, like, I guess I assume we want to just do these operations for the left side and the right side. So my instinct for like del dot v times e, do we want to use that e as the gradient of v? I'm not really sure. Is this thing even a vector? With is it? It's a scalar times a vector on the left. Well, the gradient is a vector. Okay. But I don't know if it's even the right direction.
I'm just looking at the equation and first of all trying to work out what it even means.
I guess that this what does del dot even mean again?
That's
There's
the
a word for that, right?
divergence.
Divergence?
Divergence, yeah.
Okay. I guess if it's distributive, or that's what it looks like. Give a scalar times a vector anyway.
Okay, so I think I'm starting to wrap my head around it. So phi and e are both functions of x, y, and z, aren't they? They're both, and phi is a scalar function and e is a vector function.
Yeah.
So looking at our handy little cheat sheet from Appendix F,
I'm kind of trying something. I'm rather than partial derivatives, I'm saying e sub x is just the x component of e. And then if we dot it with del, get e times e sub x. No, if it's
yeah, I'm
dotted,
buying it.
we're on a vector. Sorry, what?
I'm buying it. I'm buying it so far.
Okay.
Right, plus there, yeah. Each of these will be product rules, won't they?
Oh. Yeah, we could break this out further, couldn't we?
Well, good, because we'll get 6 terms, and then I bet we can pair them into triples that we can somehow rearrange to get the thing we're trying to prove.
Hmm. Outside, track that a little over there. Oh yeah, we probably will get. Yeah, we'll probably be able to notice this is the same as some other quantity. I see what you're saying. DZ B. Ugh. Writing. Okay. Oh, yeah, we do have a gradient of phi hidden inside here. Dotted with E. Ah, okay, yeah. So if I collect these terms in red, we can make the claim these are the same as,
That's this.
oh, oh,
Sorry.
nice. No, 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 that's completely fine.
Let me move
Yeah,
that a little bit
nice.
like that. Yeah, those are your three red terms, right? So that was the first term on the right side of the equation we're trying to prove. And the other ones are supposed to be T times divergence of E, which it is, right? Yeah, we got it.
Divergence, yeah, okay.
Because you can factor phi out of those ones.
V times del dot E. Okay, nice. That's not so bad then. Then for part B, any scalar function phi, any vector. Oh, they're saying it holds, but they're not asking us to prove it. I guess we kind of did.
Okay, so they're saying, that's just a vector calculus identity. It doesn't have to have anything to do with electromagnetism.
Right.
But
1.53,
nice,
2. Oh, what?
I was going to say nicely for us, it applies to our electromagnetism.
Right. Let me go grab 1.53. And 2.32. Okay. So we need to show these are equivalent expressions for the energy stored in a charge distribution of finite extent. Divergence theorem. What is the divergence theorem again? Ah, okay, let me screenshot that too. I don't know if we'll need the second part, but I'll bring it in too in case. A wisely chosen volume. And these are both volume integrals here. So is this, I guess this is, we're going to eventually end up with something like E squared equals like something like rho phi over epsilon naught? Is that for these two things to be the same? I assume we have to do that like not quite that simply, but I guess we're gonna have to get something that's like that.
Rho times phi.
Easily chosen volume.
A charge distribution of finite extent. So if it's a charge distribution of finite extent, we don't know what it looks like. We just know it's not infinite, not infinitely big. So we probably have to put either a box around it or a sphere around it, right? That would be my guess.
That seems natural, yeah.
So which is the wise choice?
I don't know.
We need the wisely chosen volume here.
Divergence of E.
They said Cartesian coordinates, so let's go with the box, I guess, right?
Oh, yeah, we did do that up above. Oh, yeah, the thing we did must be related. I was kind of playing around algebraically with like that second equation they have down below. But I like your direction.
Yeah, because I think the intent is we use part A to help us here.
Hmm. Divergence of E.
So what's this? Divergence theorem. Integral f dot dA equals integral divergence f dv.
So that's, I guess, the flux out of the surface from a vector field equals the divergence of the volume.
Okay, I'm trying to catch up with what you're doing right now. So you're using the second of those two potential equations.
Yeah, I'm
And
just
then,
kind of hoping to get lucky algebraically and skip the geometric
okay,
interpretation. So the divergence of E times phi, if we were to try and shoehorn in this formula that we proved, would be del dot phi minus del phi dot E? I don't know about this though. So we only had one component of the identity that we proved. That was on like the right side, so I rearranged it a bit, but I don't know if this actually helps. I have to do something like that at some point though.
Okay, how did you do that?
Um, I took the identity that we proved and I subtracted over. I noticed that we had divergence of E times phi. Like we had that component there.
I
So I
see.
subtracted over that other component and subbed it.
Okay.
I don't know. I can't imagine this is actually helpful though. At least yet. Because what we would want to get from here is just E squared dv. So we'd have to do some kind of a. I don't know what we would do to get there just algebraically. We might want to do the direction that you're saying with like taking arbitrary charge distribution and making a box around it.
Well, maybe. I don't know how to do it.
Um, um, yeah, you know, we do need to get the divergence shoehorned in here somehow in order to actually apply this divergence theorem.
Yeah.
And so rho is the divergence of E, which is probably that sub that I did down there, isn't it? So maybe at least that first step that I did is okay. But we have this phi that's mixed in here too. Like, what would we do with phi? Phi is the integral of E, or the Laplacian, or the integral of rho. Ugh. I'm feeling like it should be something we can do with this step to maybe make it into a surface integral, and then we would notice that surface integral is the same as something else.
Yeah.
Hmm.
Both of these two equations we're trying to prove the equivalence of, they're both, like you said, volume integrals, right? So can we, I'm trying to see if there's a way to use the divergence theorem to back out from each one and change them both into surface integrals.
Hmm. Like the volume integral of the divergence of f. The divergence of f is that's basically just oh, it is a total flux through the cube, of course. Okay, that this formula makes sense to me now, where it's coming from, or why these two things are equal. How divergence is defined. Um.
Oh, okay, wait a second. So the identity we just proved, right?
Mhm.
The first term on the right-hand side is the gradient of the potential dotted with E. Now, what's the gradient of the potential? Isn't that's something to do with the electric field, right?
Oh yeah, I think
Or
that's
like a
negative e. Um, yeah, true. E is negative
so
del phi.
yeah. So couldn't we say that first term we could replace it then with negative E squared maybe? That feels like something. And then when you said move that to the other side, it would become a plus E squared. Because I'm just noticing, one
Mm.
of those two equations was the integral of E squared. It's a volume integral of E squared, which is like E dotted with E, right?
Yeah.
So maybe that term is sort of corresponding with one of those equations for U.
Interesting. Well, actually, so we have, if we can show that the other part is zero, we're actually in business.
Okay, which
Because
part? The
I'm back down to like the work that I was like doing down below with like just the random algebra. Like if we separate them into two different integrals, we have epsilon naught over 2 e squared dv. But the issue is this integral right here. We need to show that it's zero somehow.
hmm.
So on the left side, I started with the other equation. So what is? Oops, I forgot my dv. So this is what the divergence of phi times e. Like I assume we have to figure out what this means physically. And since phi is a scalar, we haven't used the divergence theorem yet, have we? Oh, well, that thing using the divergence theorem is equal to a surface integral because
Okay.
it's the volume integral of the divergence. Um, the divergence of okay, so this would be the VE dot dA using the divergence theorem plus epsilon naught over 2 E squared dV. Okay, now what is VE dot dA?
What are we trying to, what do we want it to be? Or is that what we're trying to make 0?
That was my thought, yeah. Because the second term is the exact thing that we want. Epsilon over 2 volume integral of E squared.
Yeah, so this whole chain of equalities you've got here, you started with the second one and you're trying to get to the first one, right?
Right.
Okay. Why would that be 0?
I try to think about the angles between, like, can we think of a surface that's always going to be dot product is 0 when they're perpendicular? That feels wrong.
So what if we had, let's just think about, let's just go to a sphere really quickly just to think about this. If you had a spherical shell, right? Or a solid sphere or whatever, let's say the surface of it is all at the same potential, right? Then,
Okay.
so let's say it's like, yeah, that seems feasible, right? If you had a sphere where the surface was all at the same potential, then the electric field would be coming radially outwards, right? If it was a positively charged sphere. So if we integrated phi times E over that total area, oh, maybe by symmetry that's 0 because you're integrating a vector, right? Oh no, it's a dot product. Sorry, it's phi E dotted with dA, right? I don't think that will be 0. It doesn't feel like it's going to be 0.
And so even though our Gaussian surface is a sphere, we don't know what's inside it. Like, the flux might not be evenly distributed, I don't think. Like, if you had a
Yeah, but
cylinder
I mean,
inside there, I guess the total
yeah.
is still the same. Okay.
I mean, aren't we trying to show? We're trying to show that what we're doing is valid for any given surface, right? Any potential, any electric field, any surface, right? I think we're trying to prove this is true in general.
Right.
So I'm saying if you had a sphere like this that had like little positive charges all over the surface, right? So it was, I don't know, won't draw all of these, but then if you had E coming out like this, radially outwards at every point, then if I do that integral you've got there, these are my E vectors, right? And my dA vectors will always be parallel to them, right? Like right here, here's a dA vector. They're at right angles here at this
Right.
point. So the dot product will be cosine 0 is 1. So I feel like if the phi is constant and if the E is radially outwards, then when we do that integral, we don't get a 0, I don't think.
You're right, we wouldn't. Does the phi have, like, the phi doesn't, your equipotential surface isn't always a circle, though, or a sphere.
Right.
Or maybe you could make the argument that if you go out far enough, it'll look enough like a sphere. If it's not 0, though, it's going to mess this thing up. It's weird because it's nearly like that normal kind of flux integral that we used from chapter 1, but the phi being involved here must change it somehow. And think about how, like, shoot, well, now doesn't make sense to me, but I thought the book was starting like E and phi is almost having this kind of like inverse relationship with how you need the negative sign, where phi increases, where E decreases or something. I was trying to make something like that. Or would we apply that phi is the gradient of E again? Or the other way around? Okay, just playing around with more stuff. If we... complete guess, but if we say that E is minus her phi... Wait, God, I'm gonna mess this up. E is minus del phi. So if we say... we still have that same phi times minus del phi dot dA. Does that mean something?
I don't know. I feel like I don't know if that's worth pursuing. I feel like I've convinced myself that can't be 0, though. I don't know. I feel like I've convinced myself that shouldn't be 0. I'm looking back through what you did here, but I see what you did. I'm questioning this right here.
Okay.
This equation, this equality right here, I'm going to question. Let's see, that's where you used our identity, right?
Right.
So you said the integral of the divergence of E times phi dV. Yeah, that's where you subtracted the one term over,
Right.
because you had phi times divergence E. That seems believable. And then we argued that we could write that as E squared. Hmm. I don't know. I don't see any mistakes. I mean, I just don't see why this should turn to 0, though.
I'm trying to figure out a surface that would get us that. That's what I'm hoping for. But we need it to be perpendicular, and that's not easy to accomplish with a field that radiates outward.
Oh, that's a shame. The identity was kind of easy to come up with.
Yeah, but
What's it
we can
telling?
do the
What's it
math,
telling
just not the
us?
physics.
I know. What's it trying to tell us? It's telling us that the divergence of phi times E is equal to the gradient of phi dotted with E plus phi times the divergence of E.
So they do say in part B that this is just like a general mathematical fact.
Yeah.
It also holds for like this interpretation of it, but it's possible it doesn't necessarily mean that much physically. I mean, I guess it still should mean something.
It should mean enough that we can prove that those two energy equations are equivalent, at least.
Yeah.
Apply the divergence theorem with a wisely chosen volume. Oh, so let's see. What about if we take, so if we take the identity that we derived and then we integrate both sides, we do volume integrals of both sides. What about trying that?
I don't know how is there a fundamental theorem of calculus for like volume integrals with divergence like that?
I think that's
Is
what
that
the
what you're going for?
divergence theorem, yeah, because I think that's what the divergence theorem really is.
Oh, yeah.
And then I'm thinking we can use the divergence theorem that you copy pasted over, but where it says F, we can put in phi times E, right? Where that F is.
Okay.
Would it help? I don't know, but it's might be worth trying.
I think as well, yeah, it's a direction. So we have we're taking the volume integral of the divergence of v times e.
Yeah.
And then we're applying the identity. It's del phi dot e plus phi del e.
Phi del dot E.
Okay. Oh, dot. There we go. dv.
Now can we say this is the integral over a surface of phi E dotted with dA. And now we have to think of the right surface, I guess. A wisely chosen volume and a corresponding wisely chosen surface, maybe. Well, I guess you choose one, you chose the other, right?
Yeah, they should be the same thing. I'm still stuck on these algebraic manipulations. I feel like it's maybe a bad habit, but the divergence of V is rho or epsilon naught. It just looks so tempting to me. I don't know what we do with it though.
Wow, I feel like we're getting close here, right?
Yeah,
I mean,
we could.
what you
Huh.
just wrote over there looks sneakingly like the two formulas we're trying to look at there.
Yeah,
Like if you multiply a 1/2 and then you bring that epsilon naught up, you sort of have both those two things.
because I guess what we would want is epsilon naught e squared dv equals. So we're back around to getting that thing to be zero, at least with my how I'm interpreting this here. So if we use your left hand side there of the surface integral, we still need something to be zero, I think, to get the thing I just wrote to give us the desired result, I think.
Yeah.
But I think that's this is the same predicament now.
So if I multiply by epsilon naught, I could get epsilon naught integral surface VE dot dA equals epsilon naught integral volume minus E squared dV. Let me split it into two plus integral V rho dV. Is that right? Did I do that correctly?
Uh, yeah, I agree. You multiply through by epsilon naught and copy down, right?
And those two terms on the right side are kind of like the two terms you've got a couple lines up. Yeah, you're right. So if the left side of this is, if this over here was zero, right?
Mm-hmm.
Then we could move this thing, left and we'd have it, wouldn't we? I think.
Exactly. Yeah, we'd be done. Um, so yeah, I'm not too
Okay,
optimistic
so
about the dot product being zero, but it seems like we're supposed to choose something that gets the dot product to be zero. What does
well,
phi
aren't
times
we?
e look like? Sorry, what?
I feel like we're right back to what you were trying to show was zero, and then I was trying to show it wasn't zero. So maybe I'm
Yeah,
wrong. I
I
must be wrong.
hmm. I mean, we've been thinking about the flux like with just e, but we have phi times e, and does phi times e somehow make the vector point a different direction?
No, well, I don't think so because phi's a scalar, right? I mean, phi's just a number. I mean, it's just a number at every point in space.
It could still
So,
like flip a sign though. Well, yeah, actually, it would always flip the sign.
oh, okay.
Well, I guess, but a straight like flipping all the way the other way isn't exactly what we want. Hmm.
A wisely chosen volume. Yeah, we still haven't chosen our volume, right? So is there a way to do it so that we can make that thing on the left zero?
Yeah, I haven't. I just don't know how to evaluate like for an arbitrary. I know what phi times e looks like. Like we could try and think about like try it with a cube, try it with a sphere. Um, But yeah, I guess you're right. Where even though I said like phi could flip the sign, um, we're still perpendicular, which is bad for what we want to do. If we do want to show this thing as 0, we need it to be parallel. I'm starting to think of like curl. It's probably not the right direction. They would have mentioned curl if we're supposed to use that.
Oh, I don't know. I don't trust Purcell. Purcell with his Nobel Prize in physics.
Yeah, like that means anything. God, we're so close on this one. It's just this one thing.
Yeah, one thing, but it just seems like a big thing.
Yeah, it is a big thing. So okay, the over in the work that I was doing before on the right, I did do one more step where I plugged in instead of phi times e, I subbed the e out for minus del phi.
Yeah, yeah,
And I'm trying to think about how the gradient, like where does the gradient points in the steepest ascent. So like we just have some kind of like point charge, and we have the
yeah.
negative. So it's like a point charge q. Well, I guess it's the same thing as field, so it's gonna be pointing out there. And then if we multiply in this phi, how is this thing 0? I like I agree with you where it doesn't seem like it should be 0. I just can't. It seems like it has to be, and I can't. Steepest descent. But it's multiplied by something like where the sign isn't flipped. If, as one gets bigger, the other one is decreasing, but that doesn't necessarily. It's not necessarily 0. I don't know. I thought I had a thought.
Oh,
Now I don't.
okay. I got an idea, which is probably a dumb idea, but I'm just going to say it anyway. What if we take our volume to be like infinity, right? We just go all the way out to infinity. In
Okay.
other words, we just take our volume to be infinite. Then could we just say that the I mean, I'm trying to see why the surface integral could be 0. If we go infinitely far out, can we argue that the electric field and the potential just go to 0 when you go infinitely far away from all your charge distribution? The
Huh.
problem is the area goes to infinity, right? So I don't know. I don't buy it, but it's the best I got right now.
Yeah, because I guess I'm worried that V has like that implied like 0 point at infinity. But I mean, it doesn't have to be like that, I guess. I don't know, dude. Should I try to peek at like the first sentence of the answer or something? Just try to get a hint. I'm starting to feel a little
Yeah, yeah.
stuck. Okay.
Yeah, I'm not opposed.
What number was this? 24.
24.
Okay.
Plus, we can see if we did part A the same way they did.
True, yeah.
I feel like our part A was good. I'm saying full marks on part A.
I think so too. Okay, 24. So part A. Um, okay, yeah, it's that same grouping that we did, I think.
Yeah, it seems like they used the product rule and did what we did.
Okay, and then part B, if B and E are the electric potential and field, del phi equals minus E. Oh god, scroll down just a teensy bit.
We did that, right? We did use that.
Oh, okay, yeah. So we noticed that E squared thing. Integrate both sides over the volume of a very large sphere. Did you call it? I'm gonna go for another sentence with radius r. Divergence theorem.
Okay, wait a second.
As a surface integral.
That's
I think we have the right
12,128,
set.
right?
Yeah.
Yeah, 12,128 is kind of what we did, right?
Yeah,
Yeah,
it's
that's what you
we
did.
had the
Yeah.
integrals involved, but like it's the same manipulation, yeah. So I think we're so far in part B, we're perfect. I guess we did an integral without naming what we're integrating over, but I guess that was the
A
problem.
very large sphere with radius r.
It might be exactly what you said. I guess I'm gonna go for another sentence.
And then what? Limit as r goes to infinity?
Maybe? Okay.
Surface integral phi e dot dA. We got that. E dot E is E squared. We did that. Oh, we're on fire.
Resulting equating be written as. Well, okay, they say if. Now are they gonna say they're gonna show that it is? For the following reason.
Yeah, if it's zero, sure. Yeah, we already know if it's zero, we got it. But how do you show it's zero?
They all lie within a finite region, so we can enclose them in a sphere of some radius r. Let it go to infinity! You called it! They look effectively like a point
What?
charge from far away. This is... okay. S.
Oh man. You know what? I don't get it. I don't get it.
I think this is so we can approximate any distribution we want as a point charge, and then I assume they're going to do something fancy here. On S, the field E will therefore vanish at least as fast as 1 over r squared. And field vanish at least as fast as 1 over r. Oh. Oh!
What? Oh, r cubed. Oh, is that what's going
And the
on?
surface area vanish or goes up with r squared, but b times e goes down with r cubed.
Oh, come on.
Oh, you had the idea. We just couldn't like bring it home.
But what was wrong with that little picture I drew of like a spherical surface? And I was trying to argue that if I integrated over that surface, it wouldn't go to zero. I don't buy this going to infinity and saying, well, then we can just use this with impunity, because it's like, is it true all the time or not? Yeah, that picture,
But
like,
it doesn't make it break a lot of things if you just let your Gaussian surface be infinite, effectively. Well, I guess for a normal situation, we have just E dot dA. The field is falling off as fast as the surface is growing. There is that difference here where BE falls off faster, which is maybe why math still works. But yeah, that's an interesting idea.
Oh, is that why? Because the phi, okay, wait a second. What did they say? So the surface area was with r squared,
Mm-hmm. The
and they
phi
said
is
the
1 over
field is
r.
1 over r squared, but the
Yeah.
phi is 1 over r.
So phi times e is 1 over r cubed. So the phi e, like, combined multiplied quantity is r cubed. So your ratio is a little bit different as things go to infinity.
Oh, and it's because it was a finite region. So as long as it's finite, you can get it this way.
Yeah. So it wouldn't help you for, like, I don't know, I guess like the infinite plane or something, but or yeah, the same argument would hold for like an infinite sheet. The result we have proved holds only as an integral statement over all space. It does not hold in differential form. Which is epsilon naught e squared equals rho phi. Oh, okay, yeah, fair.
Wait a sec. Let me wrap my head around that. Epsilon naught e squared equals rho phi.
It's the same equation just without the integrals. They're saying it
The
doesn't work.
integrals. Yeah. And they're saying more, aren't they? They're saying not only is it you have to have the integrals, but you have to integrate over all of space out to infinity. Maybe that's why my
Um,
little picture didn't work.
yeah, like that. I think your picture's argument they use to justify why E dot dA does work. But we just like I remember chapter one they made a point about like if the field was one over r cubed, like Gauss's law wouldn't hold, and this may be repeating that argument. Now that I think about it. But, okay, that's the entire answer for 24.
Well, that's pretty good.
Even though we couldn't quite get that last bit, we got a lot of work done on this problem, so I don't feel bad about that.
Yeah, I'm gonna say B minus on that question. Not bad. That's at least
About
a B
right.
minus, right?
Yeah, it's Girdle. Um, I know. I guess we're just a little before the 2 hour mark, but I definitely don't want to put another problem on for just like 5 minutes. So maybe we'll
Yeah, I
call the
don't
group
think there
there.
is such a thing. There's no such thing as a 5-minute question in this class.
Yeah, even the 1 star problems take a bit of thinking.
Well, that was great.
Yeah, thanks so much for coming out to another group. These questions were fun.
They were fun, challenging. I'll tell you, out of all the people doing reading groups on Twitch, I think you're doing the hardest one. The hardest one I've seen anyway.
uh,
All those other lightweights out there. Yeah, I said it.
I mean, I think they're trying to make it
Abs
more accessible though, which I'm not.
Abstract algebra and complex analysis. Come on.
It's weenie stuff. No, but
All right. Well, I look forward to next week. I'll try and get through chapter 3. We'll see if we can make it happen.
yeah, same. We can always
Hey,
take a week off or
this
something.
whiteboard was pretty cool.
I like it. Yeah, I'm gonna like say thanks to Zach for calling it out.
Yeah, what's it called?
Just webwhiteboard.com.
Yeah.
It was really quick to set up a thing, so I just did like the 5 minutes before I started stream.
Yeah, I got the hang of it pretty quickly. I mean, I probably still have to practice it to get better at it, but it seems good.
Yeah.
All right, thanks,
All
Don.
right.
Let's get back to the
Thank
math,
you.
right?
Yeah. It's a little easier, hopefully.
All right.
See ya.
All right, talk to you later.
Yep. All right. Another fun reading group. Look, let me get some music going. And then get title and category switched over. What do I want to play though for music? Let's start with this. Answering math questions from chat and internet. Oh, my YouTube stream's way behind. Oh, I think maybe my cursor just doesn't. It doesn't matter. Okay, Twitch title and category updated. Let me update my YouTube title and category. Or title, whatever you call it on YouTube. Title and thumbnail. And description. I can get StreamerBot to do this for me. Why don't I make StreamerBot do this for me? Oh, I just realized that. Okay. I can just get like a hotkey or button to click to do that. Oh, I've been doing this manually for weeks. Like a pleb. I wonder if we can do the thumbnail. I probably can't do the thumbnail. Okay. Don does all the chat. That's why I want to make a custom queue as well, because it can get, like, I'm manually getting timestamps for the problems that I work on for YouTube, and like StreamBot can do that for me too. It's going to be a little complicated to, I'm going to have to write some C# code, I think, but it's possible. Hey Zach. Thank you so much for suggesting that whiteboard app. It's really good. We just use it for the reading group, and it's the favorite one. It's easily my favorite one out of the Discord whiteboard and Excalidraw. So thank you for like mentioning that. I'm getting an image of it right now. Oh. Okay, so I did just find out the hard way that you have to pay to export it with a decent resolution. Let me see how bad this looks though, with the base resolution that they give. Screenshot it. That's a pretty big. What? This is what they gave me. The hell? It's not enough. Can you believe I want to get into applied physics in uni? I mean, I don't know. I don't even know what you actually did study, so I guess I would believe it. Screenshot and splice. Ah, that's work though. I need StreamerBot to do that for me too. But what does the PDF do? Let's try that. Oh, no. Okay, well, that part of it sucks. I guess screenshotting really is the way. Screenshotting is going to be particularly high resolution either, though. Yeah, like, I would have to do, like, 8 screenshots or something. Broadcast media. Still up with a career in data science? Oh, okay. If it works, I guess. Okay, well, that part of it sucks. I might just sign up for an account. I wonder if I can make them publicly available through the site, and it'll be higher resolution, and at least provide a link to it. That's really annoying, though. I'll deal with this later. I'll keep the tab open. But the experience of using it is still like the best one. They just monetized it, which I guess is fair. May sign up for an account too? Yeah. I mean, I would just pay for it if this was like something I was doing for a living. I wonder how expensive it actually is, to be honest. I'll look into it more later. Unbox is still in here too. Okay, so I think we got everything. 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 I think we Okay, I don't think I have any math questions that are pending for me. I want to do a little tech test because I'm playing in a DayZ event tomorrow, and assuming that I actually wake up on time for it, which I'm a little worried about. But as part of that event, the devs are like sponsoring it with game keys, and they're going to give everyone who plays the chance to give out a key to their communities. So just as a tech test, you're not going to win anything here. I kind of want to test Nightbot's giveaway thing. Oh, it's just going off active users. I want to do like a keyword though. Everyone is eligible. So like, I know, would someone mind doing like exclamation point test? I just want to see if this thing like actually works how I think. Oh, hey, okay, so Zach lit up. I can mark you ineligible though if I wanted to be mean. Can I enter my own giveaway to make sure there's a chance? Okay, I guess not. Random number? Huh. So if I roll it, okay, Zach would have won this. And I could keep on rolling it. I win, yeah. There are no. Oh, okay. So once you win once, it makes you ineligible, I guess. Okay, that's good to know this thing works, and it seems pretty simple. Thanks for doing that, Zach. You know what? Your prize, the thing that I am giving away to save, will buy. Is Web Whiteboard and Miro the same thing? I assume Miro is the company behind it. Miro.com? AI-powered visual workspace. It's free forever. Well, what the product they're saying is free. Or they're saying everything is free. The online whiteboard one. Solutions. Whiteboarding. I mean, it is technically free to use. They just lock certain features behind the paywall. That's probably their technicality thing. Oh well. Look. The light version and the better version of both. Really? Huh. Yeah, I mean, I'll try signing up with an account after the stream and seeing if that unlocks anything for me. Yeah, it's the company that makes this. Like, we're just looking at their like homepage. Okay. Um. What are we gonna do? I think maybe we'll look at the math Discord for questions. You would prefer chalkboards today? How much did you pay him? Don't believe that for a second. How many channels are open? Not that many, and they're just not getting cleaned up. Mini rant about chalkboard. It doesn't take much for you to go on a rant about chalkboards. Whoa, what's happening here? Oh, this looks terrible. I feel too stupid to read this notation. I know what these mean individually. This is considered real analysis? Okay. I guess it does seem like it. Let me put my mic up 1 second. Hey, Obi. Big slate payout. Or solutions just magically appear on the surface in front of you by just thinking about it. Oh, so these primes aren't derivatives. They're just f and g individually. How is that not true? And what is big M? Define them similarly. What else am I defining? Like, I don't know. Hey, Lubert's supremums? I mean, what have people already said here? I don't understand, how did he come to this conclusion? You could have, oh wait, maybe this isn't so, oh, maybe, okay, the notation is terrible. Maybe I do get what it's saying. Oh, M is for the supremums? Okay. Hey, Malfi? I'm probably saying that wrong. I'm just looking on this math Discord server for questions to answer. We're just looking at this one to see what's up with it. Okay. But I think I get this now, where it's like, it's really complicated notation for just saying that the infimum of two things added together could be more than the individual infimums added together. And I need to, it's going to be because one is positive, one is negative. If you have a function with infimum like -2 and +2, well, maybe we should use +3. If you add the functions together, you get -1. Well, actually, no, that doesn't make sense. That doesn't get me what I want. I've literally figured this out multiple times before as part of Zach's analysis class, and I need to work it out again. Using my whiteboard. Well, if you're on vacation, is a bit of a change. Oh, yeah, I bet. No, I'm trying to imagine these functions, I guess. Like, why? The infimum. Okay, fine. You win. I'll actually get up out of my chair and do something for once. Yeah, I mean, I think they're just asking conceptually why that is. I didn't even get my markers and eraser out for the stream. Basically, like they use really complicated notation that made no sense to me, but I think what they're really asking about is like this thing here. And I assume this is going to happen when the infimums have opposite signs. So if we just say we have a parabola there for f of x and a parabola there for g of x, we would have, but this is still like the same thing. This is what I don't get. Like, am I constructing my infimums wrong? Do I want like a constant function or something? You haven't looked at math since the end of the semester? Oh yeah. What are you studying, Malth? Like what kind of math are you doing? What situation do we get? How do we do this? We have to make it because the issue is when you do f plus g, you're still getting -3 for your combined infimum. Do you maybe have to do something a little more, a little fancier? I feel like I thought it was something as simple as just opposite sign mess this up. But could you need x equals -1? Oh. You're studying math used in, oh, physics. Oh, cool. That's awesome. X is -1 for x less than 0. And 1 if x is greater than or equal to 0. G of x is 1. G of x is just the reverse. So the infimum of each of them individually is -1. But if you add them together, you get 0. Okay. That makes sense. See, I needed to make them not on the same x value, I guess. I was about to do something a lot weirder, but that's probably the easiest. Example to use. Yeah, there's some parabola picture down below this. That's probably why my mind was on parabolas. Well, for that example, they get equality. Yeah. They're asking like why it could be greater than. Yeah. So I'm on board with that. I just want to catch up with the conversation because I don't want to. So these two in FEMA are both 0. But if you add the parabolas together, sneaky. Looks like mountains? Upside down mountains, sure, yeah. There's another one below that I think has it upside down. And yeah, Moth, I think that I've been doing this physics reading group that actually just ended like 20 minutes ago for electricity and magnetism, and like studying physics is so like cool because it reminds me of like why I like learning math, seeing the actual application of the things that I have learned about just in like the like that are just like they're purely taught about math but without the application. So it seems like the person is on board with this now. I doubt I'm gonna have much to add here, although I guess maybe solid exercise to do for my own knowledge. Abstract algebra simp. I just read that person's name. I saw the abstract algebra. I didn't read the simp part. Oh yeah. Okay, that person's all good. Help factoring this. Well, it's not factorable. Just make sure I'm not. Yeah, they're irrational. You have to go to bed, you guys have a new sub. Oh, well, thank you so much, Moth. Hope you sleep well. Ah. Someone else typed. I'm gonna let them do their thing. I just refuse to be an extra voice when someone else is already going to try to handle it. Unless it's really going off track. Yeah, Joseph, same. Oh, this looks terrible. Make it bigger, though. Make the terrible thing bigger. On a table are some red and blue cards. If two players take turns picking two cards, two players take turns picking two cards. If two cards picked are the same color, both cards are replaced by one red card. What? If two cards picked are the same color, both cards are... Okay. Two cards picked are different colors, both cards are replaced by one blue card. When one card remains, you win if it is blue, your opponent wins if it is red. This is a complicated game. It's really not. I'm too stupid to figure it out. Must the game always end, or can it go on forever? Well... They don't say what happens when you run out of cards. You could have it if you stacked the deck or got really lucky or unlucky. You could always just have, well, no. Sorry, never mind. No matter what. Sorry, yeah, they're either the same color or they're opposite because there's only two colors. I thought there was some third possibility. So I'd say it should. This seems like a convergence question. It should have to end because you're reducing it by half each time. Or sorry, you're subtracting a card each time. Every single hand, you take a card out of the deck effectively. And I don't see how you can get into a loop because you're never adding cards back in. Who wins if there are 8 blue and 11 red cards to start? Is their order not important? Parity invariant. I know enough about this to figure this out the way they intend. And say, true, Bluebird. I assume parity invariant means the order doesn't matter. Which means we could just make an arrangement that's potentially easy to calculate. What did the person say in Discord? Because they did put some text in there too. Prior raising game mode 10 because each case reduces the total number of cards by 1, ends with there's 1 card remaining. Always be an odd number of 1 color. Yeah, they say it's parity invariant. I don't know what, like, I did take a discrete math class technically. We never even used the word parity though, so I guess it means something in physics too. There should be a class on discrete math, but discrete is spelled the other way, like you're doing math secretly. Oh, it's a PDF? Okay, thank you for downloading that. Mod 2? I'm already out of my depth. Okay. The cough drops I usually buy were out of stock. So I bought these cherry cough drops, and it is the exact terrible cherry medicine flavor that you would expect. In case anyone was curious. Do we need to play through a hand or two to see how this actually works? Let me just check the Discord again to make sure no one got to it. Nope. So I don't know what I can do this problem, but let's see. Well, let's at least try with it. So the situation they give us is 8 blue, 11 red. It's kind of a lame game. Like there's no choice for the players to even make. So let's go through like maybe some simple cases where we can hopefully just look at it and see what's going to happen. So if we have all 8 of the blue cards on top of the deck, and then the 11 red cards, what happens? The first draw, they'll be the same color, so you get a red card. So then you have so you take out 2 of the blue cards, you put a red on top. The red goes on top, right? They just say replaced. I'm assuming that means replacing on top. Then you have 2 opposite ones, which means you put a blue on. No, 6 blue. And so that pattern is going to continue until we get to 1 blue, 11 red. Can I figure out what turn that's going to be? Is it going to be... Well, you go by 2s, I guess. On round 5, we'll have 4 blues, 11 reds. Round 6, we'll have 2 blues, 11 reds. So let's go... On 7, we take those 2 blues out, we get a red. So we just get 12 reds. Because the same color is... That's what Penbox is saying. Sorry if you can hear that chewing. I forgot about that. Sorry. Red, red makes red. Blue, blue makes red. Or red, blue makes blue. The number of blues stays the same, mod 2. Oh. So, because we have an even number of blues, we're going to end up with 0 blues and 1 red, which means the opponent wins. And I guess it wouldn't matter. Yeah, why would it matter who goes first? Oh, wait. Oh, sorry. Oh, you want to have the... Sorry, it's not always me if the last part is... Well... I feel like the question is a little vague. Maybe I'm just not used to these types of questions. Because I don't know what exactly mean by replace, whether it means top or bottom. Maybe it doesn't matter. And then when 1 card remains, does it matter who draws the blue card? Like, does you win if it is blue mean I always win if it's blue? Or does the person drawing the blue card win? I assume if they're asking does it matter who goes first, it means the person who draws the card. But let me... Alex points out, I think something that's probably important. There's 2 scenarios where you get a red card, only 1 scenario where you get a blue card. And that always involves taking out 1 blue card at the same time, so you're always staying even or odd. Hey, SPQ. red increasing by 1. Blue stays the same, mod 2. So do you never end up... I guess what that's saying is you never end up with a blue card as the last one. Which... The solution I got to, we have 12 reds, and it's only ever going to be red. Huh. So if you start with an even number of cards at least, you physically can never have a single blue card because you can never make it an odd number. Yeah, Jed. So I'm assuming, Joseph, that when you replace the card, you replace it on the same deck on top. It probably... I think the point of the question is that it doesn't even matter how you replace it, though. But yeah, what Fenlox is saying is that because of the construction of this game, the blue cards have to always be even or always be odd, no matter what. You either take out 2 blues at the same time, or you don't take out any blues, effectively. So I think just whether blue is even or odd determines the game. So if there's an even number of blue cards, you want to go second. If there's an odd number of blue cards, you want to go first, is the answer. So I think Fenbox basically figured this game out. I'm going off what Fenbox said just above there in chat. With like RR goes to R, BB goes to R, RB goes to B. And the 2 comments after that. But I think like the way the game's constructed, you can boil it down to just worrying about the blue cards. Like the blue cards are the important part. Is how it seems. But yeah, for the blues always say even or odd. The total number goes down by 1. But you're either removing 2 blue cards and adding a red, or you're not removing any blue cards effectively. Like, you take a blue card out and you put it right back in. So I think blue gets replaced with red, and red-blue gets replaced with a blue. So you're always removing 2 blues or 0 blues. That alone should be enough to figure out the game. Blue is 1, red is 0, add the mod 2. Huh. Interesting interpretation, Bluebird. Since we know that if the deck comes down to 2 blues, it turns red. We end up with 1 red. Oh wait, am I doing the order of the draw right? If the number of blues are even. Oh wait, how do you tell who wants to go first or second? I had it worked out a second ago, but now I feel like I might even need to go to the other person's turn. It does matter because you want to be the one drawing the blue card, or you want your opponent to draw the red, or maybe vice versa. No, yeah. Wait, it doesn't? You don't think it matters who goes first? So is it the other interpretation of this last sentence then, where it doesn't matter who draws the card, it just matters what the last card is? Because I was going with the other interpretation of the person drawing the blue card wins, rather than me specifically winning if it's a blue card. Like the word you is what I'm saying is vague there. Yeah, I mean, the players aren't making any choices here. It's kind of a lame game. It's like, it's predetermined, but that it's still, that doesn't mean that this isn't vague. Like, the turn order could still matter even if it is predetermined, because I don't know what you means in this sentence. They initially say 2 players take turns picking 2 cards. But if you win if it is blue means always player 1, like Jed said. Or like, if it's always player 1, I think the turn order wouldn't matter. But if the person drawing the card is the one who wins, considering the 2 red cards, there would be no winner. If there's 2 red cards, whoever goes first picks up the 2 red cards, puts a red back down, and then the next person, well, wait. Do they draw the single red card? I guess not. I'm a little confused on the logistics there, but I mean, the cards don't even, it doesn't matter if they're face down because the game is predetermined anyway, I guess. Ugh. Okay. Hey, Fi? How's it going? Yeah, exactly, SPQ. They should call it the game of life. The name's already taken. You can type it out there in chat, or you can put it in my Discord. Being interpreted as the player drawing the card. As a player, as whichever player caused the single blue card remaining to win, or you random cards and keep them face down. Maybe. It's basically like isn't like War, that like card game that like you play as a kid? I assume that's predetermined too. If you know how the deck is. Well, I guess War, that's not quite as predetermined, but it's basically the same thing. Like, or it is a lot more variations at least. This one is like a lot simpler, like you just count the number of blue cards. I graduated with a bachelor's in applied math like 6 years ago, Fi. Player one always wins if it's a blue card. It's not? Like, if you already know how the decks are, can you predict who the winner is? There's no choices to make, are there? Hey, Pen Center. Even if you have all four aces, you can lose them. Maybe I don't remember how. Oh, if there's a tie, maybe. I don't remember. Player always wins if it's a blue card. No matter who drew the previous two cards. Ignoring the above. We're just working on this, they're calling like a discrete math question, which I guess it seems fitting. It's basically determining the outcome for this like card game. And we're stuck on the phrasing of this where the last sentence in the prompt says when one card remains, you win if it is blue and your opponent wins if it is red. But you could mean like I always win no matter who caused, like if it's blue, no matter who caused it to be a blue card. Or it could mean whoever drew the card and like, has a blue card or whatever wins. And so I try to help this person out in the math Discord, but it's really hard to like, I might have to hard time explaining like how ambiguous that is verbally, much less in text here. Yeah, I mean, you don't know how War is going to turn out if you don't know like the order of the deck, but honestly, I guess I forget exactly how it's played. But yeah, I think you win in the card game War by depleting your opponent's deck, right? And if you put out a card that's higher, you get their card and you put it back in yours? I don't know. Okay, well, let me try and adapt it to what you were saying. I don't know. I don't know. I'm just gonna leave it. I think the idea is experienced these types of questions though is that you the number of blue cards always stays even or always stays odd. In each of the three possibilities, trying 2 reds, 2 blues, or 1 of each, you either remove 2 blues from the deck or 0 blues. No matter, so if you start with an even, you're, so if the person asking the question starts with an even number, I don't know. We can predict the final card is always red. And the opposite, and the final card is blue, we start with an even number of blues. However, I don't can answer. I think I don't think that U is a big deal, Jet. Or blues, we can predict the final card is always red and the final card is blue if we start with even number. Wait. Oops. Odd. What I said at the start. So I'm not sure on that part. Right, it's removing second person. Oh, that's fair, yeah. Documentation. Who even needs documentation? Well, you need better customers than Jeb. The way they would read it, true. Wait. I'm not messing with this. They said it's a. They said it's a quiz. I don't know. Maybe I'm misunderstanding. I'm not going to be involved in that. I'm just going to be a bystander. I'm not going to be part of the solution. Almost everything this one person is saying has the word bro in it. I'm getting bored. Those people are talking back and forth too much. Person's done. Well, this looks. Oh wait, we got electricity and magnetism. What? Let's see. I don't know why this is in the math this part, not the physics one, but let's see if we can do it. I think it's gonna be catenary involved though, so add the word like in front of like every other word. I haven't been paying attention to it. I used to be pretty bad with the word like. I feel like I still am, but I haven't been paying attention to it, so. The word hella, though, I will stand behind, and I will use that all the time, shamelessly. The word like, I think that's shameful, but hella is just a good word. I bet there's like a known formula for the arc length of a catenary, because isn't that like the entire idea of why we have them? Like it minimizes the arc length between. No, they wouldn't minimize it. It's something about like minimizing the potential energy or something. Oh, they already gave the formula for part A. There is a formula. 2A sinh L over A. They're asking about part B. In C. Like what? This is like hard to like read. Based on the word on the E, I, L, and K keys. Yeah, but my keyboard is maybe it's like 4 years older, so I think I bought it during the pandemic. The WASD keys they're basically the same as all the others. What? It's like I don't think that's a bad time to use like. That just means that's just another word for about there. I remember in like 5th grade, I had a teacher who had a pet peeve for like people saying like too much. And this one kid, used like properly in a sentence for like saying, oh, I like this thing or something. And the entire class like with him and been like, ooh, you said like. You just use it twice. Back in like 5th grade. Yeah, and I don't think that's so bad because you might not remember if it's exactly like, 4th grade or 6th grade or something around 5th grade. Like, I think using like as something that means like about, I don't think that's so bad. But putting like we're at in a place where it doesn't belong exactly like exactly. No, that's the reverse situation. I'm saying sometimes when you say about, you can also say like. If you say like, it doesn't make sense to say about, usually. It's a one-directional implication. I haven't even read part B yet because I'm too busy trying to defend myself from Jed in his verbal attack on me. No. Lowercase L. Let's see. It said exactly like he should be banned from like the New California Republic. We need a bot that adds like into every chat, just like a butts bot in Tal's chat. I think butts bot is not a thing anymore. Say like the wire is like placed in like a constant electric field. E external of x equals E naught field pointing from left to right. See the sketch. The person kindly did not include the sketch. That's perfect. I think we can figure it out without it though. So we'll apply a force of Q epsilon naught on the electron, where Q is the charge of the electron. Compute the work the external electric field does on the electron as it travels through the wire. The force is not applied in the direction of motion. Is the electron going right to left or left to right? That seems important. The sketch might say that if they actually included the sketch. Femlux, you're saying it's going to be Q times epsilon naught times 2L force times distance. I agree, except that it might need to be negative. Well, they're saying it's... I guess it's positive, because they're saying it's opposing the motion. So I think I agree with your answer for part B there, $10. The wire has n electrons per meter. Compute the total work done on all electrons as they move a small distance h. Is this gonna... Are we getting the current here? With derivatives. I rarely hear you... Really? I feel like and oh are the things that say the most. But I don't... Maybe I just pause. Maybe that's what I do more. I haven't been paying that much... Like, if someone goes or a lot, it definitely gets annoying, but I don't do a good job of like paying attention to it for myself when I'm on stream. I don't know, corrupt? I'm just gonna say yes, and if I'm wrong, then I don't know. What do you expect from me anyway? I've heard of the Riemann zeta function, but I don't remember anything about it. Or zeros. I'm sorry, I feel like whenever you ask me a question, my answer is I don't know how to do this. And that's another where I don't know how to do this. Oh, that's a Riemann hypothesis? Okay. You're just memeing then. I know the Riemann hypothesis is like the Millennium Problem. I don't know the actual statement of it, though. I guess that is the statement of it, so now I know, and I'll forget it in 5 seconds. I'm about to go, but I caught myself. Why is n electrons per meter? Calculate the total work done on all electrons if they move small distance h. If one electron moves from x to x plus h, you do an amount of work that is QE0 times h, no? And if you have n many electrons doing that, well, this feels like an integral. Prove this rule on a scrap of paper, but unfortunately it was lost. Oh. Yeah, I proved it in the margins of a book, and it was a divine proof. But yeah, I forgot it on the bus. Compute the total work done on all electrons. Like, or is it just as simple as doing n times? This feels too simple. Because as soon as, like, going from x to x plus h makes me think of a derivative. But, like, why do we even need that? Compute the total work done. I don't remember if this is Koch or Cinch, but, like, I assume that maybe trying to build towards the relationship between the two, where if you take the derivative of one, you get the other. Yeah, that's my assumption too. And I guess it's n electrons per meter. So you'd have to multiply by the 2L again for the number of electrons. So maybe n times 2L times Q times E0 times H. Yes, BQ. I think the card game person, is that the bot? No, yeah, it's the bot. It's not? What is it? Well, I was saying it's n times 2L times Q times E0 times H. But I assume that's, you have a fundamental issue with that, not that issue. I mean, if the field is constant, I don't think we have to do an integral, or it would... It's like the displacement in like the space-times. You're saying not to have the H at all? Or are you just memeing and you want to put like in there? Maybe I just should... I'm debating just not responding to this one, because I feel like I gotta be missing something. I think it doesn't, because in part B, we're given it's a constant field. No, I don't know what would produce that, but if the field is constant, your position on the wire shouldn't matter. Are my headphones out of balance, or is this just really in my left ear? Sorry. My headphones were out of balance. Okay. Ugh. I don't know. Maybe I'll just move on for now, because I don't know how you... If it's not the simple answer, and I feel like it's too simple, I don't know what you do instead, and I just said do. I haven't done my shill duties? What's my shill duty? Shilling for like the... Oh, Paul's notes? All right, guys. Well, let's have a quick ad break. I need to do this ad read for Paul's online notes. I have been using Paul's online notes for 10 years, and it is, let me tell you, it is the best. Tell about a time you've used Paul's online notes in your personal life. Well, I just gotta say, Paul's notes... Dude, if Paul's online notes wanted to sponsor me, I would do it for... I would pay them to sponsor me. I wouldn't even do it for a penny. Oh, good. There's a contact me. This looks like probability or something, doesn't it? I don't want to look at that. If I don't immediately understand it, it's not worth doing. Oh, Lagrange polynomials form a basis in PNR. Yeah, I can definitely do that. Looks like someone got that. Oh, hey, I recognize this person. Or they're doing category theory though, so if they're involved in a question, I probably can't do it. Oh, yeah, that person has the idea. Just show it follows the Pythagorean theorem. That's the word. I assume that's a binomial expansion. Oh. Never mind. They closed it. Yeah, someone else is in that one. Dang. I think the Discord is tapped out. Still a quick look at Reddit, but I might just also wrap things up. We'll see. I haven't been on Reddit in a hot second. I don't know why. I do kind of prefer it to that Discord, but okay, this looks like something weird. I wish they said how they're supposed to get a confidence interval, like the mean, the standard deviation, standard error, but I blank out no matter what resources I use. A lot of stats classes will just have you plug the table into a calculator and tell you how to make the calculator do it for you. Maybe they have to do it the old-fashioned way and use the formula. I'm not sure how to help that person, I'm going to be honest. There's too many possibilities for how they're supposed to do it, and I'm getting a little lazy. Haven't done this in a minute. 3, -1, 1, lambda. So they get a repeated root of 2. And that apparently corresponds. Are they sure that work? I guess with 1, 1. How do you get the second eigenvector when you have repeated? Which I forget. Is there even a second one? As long as since I've done this. Oh, hey, pause all my notes. Go check it out. Hashtag ad. Oh, you take the eigenvalue you just got and you make it your answer column? I forget why that is. I'll probably never learn why that is. Okay, so they got their one solution right there. Eigenvalue 2, vector 1, 1. Sure. And then they're asking to get the other solution. So it's equal to 1, 1. They solve it again. Did they just do... I guess it doesn't matter, that one right there. See, I get 1, 0, that's probably fine. I'm going to plug in Wolfram Alpha after, just to make sure, but let's give it the old eyeball check before you go to Wolfram. So they get 1, 0 for their second eigenvector. Is that considered an eigenvector, or is that just another solution? I don't know. What is this over here? Oh, I thought they were supposed to be the same. Oh, I guess they're not the same vector. What the hell? I think it's unless I've done this. Ugh. I gotta be honest, guys, it's kind of hot to say again, and I'm like, I can feel my brain like slowly crashing, so maybe I'll just call it. Yeah, I think so. So I'm going to cut the YouTube stream off here, and on Twitch we'll look for someone to raid if there is anyone. So if you're here on YouTube, I appreciate you. I'll be back on YouTube on Tuesday. So see you, YouTube.